This segment of our course deals with tapered bores. All of the couplings you've been working with in the last few segments were equipped with straight bores, like this one. However, a large percentage of the couplings now in use have a tapered bore, like this. The advantages of this type of coupling are that the tapered bore seats tighter on the tapered fit than the straight bore type of coupling, and that the tapered bore coupling is easier to install and remove. We'll show you why in a few moments. Another point to remember is that all types of couplings may be equipped with tapered bores. In other words, you may find tapered bores on gear, grid, disc, or even rigid flange types of couplings. The tapered bore of the coupling will not really affect the assembly of the coupling itself. The only real change will be in the procedure used to install the coupling hubs on the shafts. Now that you know what a tapered bore coupling is, what it looks like, and why it is used, let's go through the complete installation and removal of a gear coupling equipped with a tapered bore. First, dismantle the coupling, like this. Now, calculate the taper of the coupling fit on the shaft and the taper of the bore in the coupling hub. Since there are a variety of methods now in use to obtain the taper measurement, your instructor will fill you in on the procedure recommended at your plant. Once you have determined that the tapers are the same, check the fit of the shaft in the coupling bore. This is done by applying a light coat of blue layout ink to the shaft fit, like this. Then place the coupling on the shaft lightly, seating it firmly but not too tightly. Rotate the coupling about a quarter turn. Then remove it from the shaft. You can now check the fit between the tapered fit of the shaft and the tapered bore of the coupling by the bluing pattern. The pattern should show full contact around the shaft and along the whole length of the tapered fit of the coupling. Your next few steps are identical to those you performed on the straight bore coupling. Measure the keyway width and depth in the shaft and coupling, and obtain the appropriate key. Try the key for a close sliding fit without binding. Now measure the shaft and key dimensions and compare them against the coupling bore and keyway dimensions as you did with the straight bore coupling. Check the measurements to be sure you have the correct clearance for the key. As you did before, install the bells of the gear coupling on the shafts and move them back on the shafts. Protect the seals from the heat of installing the coupling hubs. If the specifications require an interference fit, heat the coupling hub to the correct temperature as set forth in reference B in your workbook. This temperature will vary according to the required fit and the taper of the coupling to be installed. Your instructor will show you how to calculate the correct temperature to which the coupling must be heated before it may be installed. Before fitting the hubs, you should determine how far the hubs must go on the shaft. Then, mark the point on the shaft. Check the temperature of the coupling hub frequently with a pyrometer when heating it. After you've done this, slide the hot coupling hub quickly to the mark on the shaft, using asbestos gloves to keep from burning yourself. When the coupling stops, check its position against the reference mark you made on the shaft. If the coupling slid onto the shaft too far, it will be necessary to remove it and allow the shaft and coupling to cool before trying again. If the coupling hub did not slide onto the tapered fit far enough, remove the coupling hub, reheat it, and try again. In either case, it will be necessary to recalculate your temperature, since the first temperature was apparently not correct. After the coupling hubs are installed firmly on the shafts, allow them both to cool. Then, tighten the lock nut firmly against the face of the coupling. Once the lock nut is tight, tighten the set screw to hold the lock nut in position. At this point, the two pieces of equipment to be connected by the coupling must be properly aligned. After they are aligned, complete the assembly of the coupling as shown earlier in this training module. The procedure will be the same as that for a straight bore type. Removal of a coupling with a tapered bore does not differ too much from that of straight bore couplings, except that it is easier. Once you have the coupling bells unbolted and pushed back, you must record the distance between the coupling faces, as you did with all of the couplings so far. There is also another measurement that you must make on a tapered bore coupling before you remove it from the shaft. You must measure the distance from the face of the coupling to the face of the shaft, like this. This measurement will tell you exactly where the coupling hub is positioned on the shaft. It is used when you reinstall the hub on the shaft later. You will use the measurement to make sure that the hub is installed in the exact same position it was before it was removed. Once you have these measurements, loosen the set screw in the coupling lock nut and back the lock nut off about 1/4 of an inch. To remove the coupling, attach a coupling puller and break it loose. This is where the advantage of the tapered bore becomes obvious. Once the taper breaks loose, you simply remove the lock nut and the coupling hub. It is not necessary to use the puller to pull it all the way off, as you did with the straight bore coupling. However, always remember to leave the lock nut on the shaft until after the hub is broken loose. If you don't, you could be badly injured when the hub pops off the tapered fit. We'll have some final points to make on couplings after you complete exercise number 7 in your workbook. The final segment of our module deals with lubrication of couplings and general safety practices now followed at the various plants. First, as you already know, rigid couplings have no movable parts. Since there is no friction, rigid couplings do not require any lubrication. This also holds true of the flexible disc coupling. There is no metal-to-metal friction. Therefore, no lubrication is needed. However, both the gear and the grid couplings have direct metal-to-metal contact during their operation. There is friction generated, and lubrication is required. Although there are some specialized types of couplings that use oil for lubrication, the gear and grid couplings we have shown you in this course utilize grease. The grease is injected into the coupling through the bottom lube fitting, like this. When the grease begins to squirt out of the top lube hole, the coupling is sufficiently lubricated. You can imagine what would happen if grease was injected through the top half. Grease would vent through the bottom hole before the coupling was full. Using the proper type of lubrication is very important. Always check the manufacturer's manual for the coupling, and use only the lubrication indicated, or a suitable equivalent as dictated by your plant. Another very important point to keep in mind at all times around couplings is safety. Remember that couplings in operation are spinning at very high speeds. This means that the couplings should be installed, aligned, and balanced properly. Even though all of these procedures are followed, there is still another major danger area. The danger we are talking about is getting caught in the spinning coupling. To prevent this, couplings should always be installed with a guard, like this. The guard will prevent your accidentally bumping it or getting too close with loose-fitting clothes. Actually, loose clothing is not recommended when working around any machinery which turns at very high speeds. This would also include ties, extremely long hair, or anything else that could get caught. Before attempting to remove or install a coupling, always be sure the equipment you're working on is locked out and tagged out according to your plant's requirements. You don't want to take a chance on someone starting the equipment by mistake, or take a chance that there could be an electrical or mechanical malfunction. The odds against an accident like this could be about 1,000 to 1, but that 1 is too much of a chance to take when it concerns your life. Specific couplings are installed in certain applications to satisfy the requirements of the equipment or manufacturer. If you should have to replace a coupling, replace it with a duplicate of the old coupling. Don't ever replace a coupling with a different kind or type unless the change has been specifically authorized. When you are installing the coupling, always treat your tools with respect. Remember the heat when heating a coupling hub to shrink it onto a shaft. Forgetting just once could result in a very bad burn. The best policy is to treat all of your tools and equipment as though they were potentially dangerous. By doing this, you will always be prepared to work safely. Your plant will also have specific rules and regulations that you must follow when removing and installing couplings. Ask your instructor what they are and why these rules are in effect. Sometimes knowing why you shouldn't do something is much more convincing and will make a more lasting impression. If you're unsure about something, ask your instructor or your supervisor. Don't take chances. It's not worth it. We have some questions for you now in exercise number 8 of your workbook.